anybody else will introduce themselves?
I'm Gabriel, the guy with the huge name. I'm Victor.
I'm Stephanie. Okay, and our toy is called Sea Wars. Subtitled Crusaders of the Caribbean. It was originally supposed to be Pirates of the Caribbean themed. I actually did paint a Kraken on one side, so we can just say it ate everybody. I wasn't quite ready for that, but okay. Okay, you can't really hear it, but this is actually a battleship commercial from like the 1960s. 60s, 70s, I can't remember which one it is.
It's been around for a while.
So basically, I'm sure like most of us here have grown up playing the classic game of Battleship, where you put your ships in there and your friends. I know as a kid like to falls in the swimming pool, and guess, and it's a lot of like more of a mind game. It's like guessing just the squares, guessing this, but we wanted to make it more interactive, and we went with something that Battleship is classic. It's been around since the 60s. Kids still play with it. Around the 90s, it got an upgrade, so it was an electronic talking game, but this is still one more step more interactive and fun, and it also incorporates some aspects of, we basically went with cornhole, where you have to throw a beanbag into the holes, and we have a little cannon that'll launch a projectile. So we kind of took two games that people know and people enjoy, and kind of took the best parts of them and put them together. So our descriptor toys, once we get them set in there, the ships themselves will move back and forth, and the cannon is spring-loaded, and you have little cannonballs that you'll shoot out of the cannon and try to hit it, and when it lands in the ship, that is the equivalent of guessing enough of the squares to sink the ship in the classic Battleship game. Okay, so yeah, and we were going with games at age range about 8 and up because it is a little bit of complexity to figure out the spatial reasoning and the spring-loading mechanism on the cannon. So this has a lot of cool features that it can be very variable in how hard it needs to be. If you have really young kids, you can just leave it stationary and have them try to shoot it into the buckets. You can say, okay, in this game you need 2 little shots per bucket to sink a ship, or 3, whatever the case may be. And in the future, theoretically, it could be variable speeds. There's only one right now. It's accessible to a wide age range. We said 8 and 9 for the reasoning skills and the cannon mechanism that's involved. But anybody, you can play with your grandparents, like people were saying, the other toys. You can play it with your siblings, with your friends. And it's generational, develops communication skills, problem solving, spatial reasoning, and things like that, because you have to figure out, this actually does, it rotates and it makes you figure out how do I need to set it up to get the shot that I want. So we can keep going with that. Yeah. And we'll move on and show you actually our working model in Korea.
Yeah, here we have an overview of the model. Like I already told you pretty much how does that work. And we have a compression spring inside of the cannons, and we have just to regulate the angle of the cannon as well, the pressure. We are compressing the spring. So that's one of the reasons that it should be from people from okay and above. Here we have a movie of the toy nation, which never works.
So bring your mouse to the right step when you're the last one.
Yeah, and then we will see, the internal mechanisms of the moving skeleton. So yeah, we have 2 bigger gears, and actually we did some adaptation of this model we're seeing here. Because of the torque, a lot of groups experience some issues with the torque of the motors. So we added a smaller gear for each bigger one, and yeah, so the ships could actually move. Here is the process. What I thought it was pretty interesting about this project, it gives us a heads up about the projects we might be facing when we are working in real life. So it pretty much come up with an idea, the conceptual phase. People from marketing or wherever will figure out a demand, and then they will bring to us engineers, and we will model it in CAD systems, and then people from supply will purchase that, and then this is one of the process we use. It's a laser cutting. There were not those sparks, of course. It was acrylic, but we also 3D printed, and yeah, we built. And in the final result, it's what is expected. It's a having a final client pretty happy. Some key features.
So some of our key features would be static bolts or moving cannon with the track. The cannon still have a play value too because we can take it off our tracks and play just cannon and try to shoot something.
Should I use the other?
Yeah. We have our gears if you want to show children how gears work. That's it. Yeah, we can show just have the lid open. We have switches to turn this mechanism on and off because the shifts needs to be in place before we start the mechanism. The cannon was designed to work as with a compression skill, but because of our printing, the material limitations there. We couldn't have a barrel in the cannon. We had to do a shell, and the spring bends to the side a little bit, and it's difficult to aim with that. But if we had a little bit more material, we could do a barrel better. Initially the cannon was thought to have like a locking mechanism, but it was fine on compression, so we don't need it. Yeah, and the track is just a place to hold the cannon in place and be able to aim.
Okay, so our mechanism that actually moves the ships, we were inspired by shaft slider mechanism. And so actually as mentioned earlier, we had a little bit of a change because we were worried about the torque. So instead of just one gear, we have two of these for each larger gear. So in total we have 4 gears, or we have 4 motors, and these motors were chosen specifically because they were small, as we had a height limitation, as well as they are low revolutions per minute and they have a high torque. And then we designed the ships. So we have 2 different sides. Yeah, so those were 3D printed, and initially we had initially this was filled in, but due to our printing volume limitations, we ended up removing some of the material. Yeah, so some of the issues that we had with this design was just pretty much implementation. We didn't take into account a lot of the friction produced, but we tried to overcome that with the addition of 2 other motors. So how we turn this on is by using a reed mechanism. We have this switch here. There's a magnet actually attached to the end of it, and we push it forward and it completes the circuit. So we would like to make that a little bit more sophisticated, but due to time limitations and whatever, this is how it turned out. And then the box itself is a little heavy, so we wanted to in the future make it out of something else that would be lighter. And then we would have liked